ground. That's why the average person can only jump about 1.5 feet straight up. But if we had to live on another planet, say Venus or Saturn, let's find out what difficulties we'd have to endure there. We'll try Mercury first, as it's closest to the Sun. The gravity on this planet is less than half that on Earth, so you'll be able to jump about 4 feet high. That is, if you can stand the temperatures. On the sunny side, the heat reaches 800 degrees. To be there is like standing neck-deep in dark red lava on the slopes of a volcano. Oh boy! Night won't bring much respite either. Scorching air will quickly chill to minus 280 degrees. You'll also have to be patient, since one day on Mercury lasts 176 Earth days. Well, hopping from this inhospitable place to even less welcoming Venus. You'd be able to see Earth from here if not for the whirling mass of clouds above. They create a monstrous greenhouse effect, as well as immense atmospheric pressure. If you were to jump here, you'd make it just shy of 1.7 feet high, because the mass and size of Earth and Venus are almost similar, with Venus being a little smaller. Besides the constant temperature of a blazing furnace, rain here wouldn't bring relief. The clouds up there are made of sulfuric acid. Skipping our home planet, we go straight for its moon, Luna as it's otherwise called. Gravity here is less than 1/5 of that on Earth, so if you jump, you'll rise almost 9 feet in the air and won't touch the ground again for several seconds. It's hard to believe this desolate piece of space rock makes tides on Earth habit. And if you stay on the moon long enough, as in a couple million years, you'll see how much further it's gone from our home planet. Next destination is Mars, the red planet. Here, a vertical jump will take you about 4 feet in the air, if there was any air to speak of course. Mars has an atmosphere, but it's much thinner than on Earth. If you stay here until evening, you'll be able to marvel at a beautiful blue sunset. And you can probably see a mountain from here. That's Olympus Mons, the tallest mountain in the solar system. It's almost 3 times taller than Everest, and it's also a volcano, by the way. Leaping from here to Phobos, one of the 2 moons of Mars. Plant your feet firmly and don't be tempted to jump. Gravity here is so weak that you won't be able to return. Phobos is really small compared to other moons in the solar system, no larger than a big asteroid. It's almost 100 times closer to its planet than our moon to Earth. Eventually, it's doomed to be pulled critically close to Mars and shatter. Scientists believe Mars can obtain its own rings then, much like Saturn. Now, we're going to a really weird object. It's called Ceres, and it's the largest asteroid in the solar system. So large, in fact, it was later classified as a dwarf planet. It's almost exactly halfway between Mars and Jupiter, somewhere in the main asteroid belt. If you jump here, you'll be taken up almost 52 feet and then slowly fall back. Ceres is so massive that it accounts for 1/3 of all mass in the asteroid belt. Fast forward to the next waypoint, Jupiter. Being a gas giant, this planet has no solid surface, so jumping here is irrelevant. But if you must, you could only hop about 6 inches high. Jupiter is more than 10 times larger than Earth and 300 times as massive, so its gravity is enormous. There's also a perpetual storm on its surface that's been there for at least 4 centuries. Although it's getting smaller with time, at the moment our whole planet could fit into that storm. Our next stop is Ganymede, the largest of Jupiter's moons. It's solid, so you can easily jump here and make it over 10 feet high. This moon is larger than Mercury, but its mass is significantly lower, which makes gravity rather weak. Ganymede is covered in thick ice, and deep beneath that is a liquid metal core. This core is why Ganymede is the only moon to have a pretty strong magnetic field. Next, we go to Saturn, the second gas giant of the solar system. It's only slightly smaller than Jupiter, able to fit 9.5 moons in it, but way less massive. If it had any hard surface to jump